Hello everyone, welcome back to Anonymous World. Hope you all are doing well. So today is December 18th and day 18th of Cyber Advent of Cyber Threat edition is out. So let's see what we have in day 18. Okay, so day 18 is cloud playing with containers. So quickly see the note. If you are on TryHackMe free plan, the attack box does not have internet access and cannot reach AWS. You will need to install curl and the AWS CLI on your own machine in order to complete this challenge. And instructions for installing this, the AWS CLI are given here. Okay, so I have my virtual machine ready here. Now let's see the premise. So Grinch Enterprises has been gloating about their attack on an underground forum. We know they were specifically targeting organizations in a campaign they have themed Advent of Cyber. What a frustrating coincidence. Tracing the user back over time, we also encountered a reference to using AWS Elastic Container Registry, which is also known as ECR, to store container images they use as infrastructure in their attacks. So let's see if we can find out more about the attack tooling Grinch Enterprises is using. So getting started, you will need to start your attack box to run commands using the Docker container tool. Okay. So containers are a virtualization mechanism similar to virtual machines, and container images are based on the Open Container Initiative distribution specification. However, when someone talks about Docker or containers, they often are talking about multiple container technologies that work together. It is basically used to describe Docker API, which is a local communication interface on a configured Linux machine. Then the Docker daemon, a process that runs on your machine to interact with container components such as images, data volumes, and other containers artifacts. Then Docker container image format, which is ultimately a tar file. Okay, so now we know some of the basic terminologies out of the way. So let's see with today's learning objective. So today's learning objective is AWS Elastic Container Registry public gallery. So ECR is an online registry for public and private container images. We will learn how to retrieve a container image from an online registry and inspect the elements of that particular container image to identify potential security threats. So now we have Docker images and Amazon ECR. Okay, so once you are logged in your attack box, you can run the following commands to see the container images that are stored by default in your attack box. So you can use the command docker images. So let's see. Let's see if I have something on my machine, because I recently upgraded, reinstalled my Kali, so I don't think I would get any result. Okay, so I didn't got any result because I didn't have any images here. Okay, so you would if you have some Docker images, you will get output similar to this screenshot. Repository, then the tag, then the image ID, then the created date, and then the size of that Docker image. Okay, so let's go ahead. So Docker containers are stored in repositories, which are a reference to file mappings. The Docker daemon knows how to reach, and which include the container tar files. So each image in a repository will include its own image ID, the tag, and the size. For example, remnex sci-fi latest, okay, or ID image ID. So Grinch Enterprise attack. We have traced the Grinch Enterprises attack infrastructure back to a likely elastic container registry that is publicly accessible. So link is given here to the suspected AWS public container gallery for Grinch Enterprises. Let's see what's there. Okay, so it's Amazon ECR public gallery. Okay, let's go ahead. So you can retrieve the potential Grinch Enterprises image by running the following command in your attack box. So you can use this particular command to retrieve the potential images which are stored by Grinch Enterprises. Okay, let's try this. Docker pull. Then there is no need to give the latest. You can give it or not give it, because by default it takes latest at the as the option. Let's see what we get the result. it will return an output similar to this. Okay, so we can see images are being downloaded. Okay, you can run the container and interact it with by running the following command. Instead of pull, now we need to use run, then -it. So I stands for interactive, then T stands for terminal, I guess, which will open a shell inside a container image as indicated by the $sign. So once inside the container, we can do a little reconnaissance. So let's wait for this. Okay, now let's try running the second command. Okay, so now you can see we have got a $sign here, which means we are inside this container. So now we can do a little reconnaissance. Let's try using ls. Okay, let's try lsla. Okay, so we are in. We can see there are some files, batch logout bash rc. Okay, spoiler, a good place to check next is environment variables. In Linux and especially for containers, environment variables may be used to store secrets or other sensitive information used to configure the container. Okay, so we can use print env or simple env. Okay, so hostname is given, then path is given, and then API key is given, which is something interesting. Okay, and we have stumbled on an API key, which I am guessing Grunge Enterprise didn't intend to leave behind. Okay, let's go ahead. Bonus challenge. So a container image is composed of a number of layers. Perhaps there is sensitive information in an underlying container layer that Grunge Enterprises didn't clean up as part of their build process. Okay, so a container image has many number of layers which may contain some sensitive information and which may Grunge Enterprises forgot to clear up. So one key reason that developers and attackers might package their application in a container is that a container allows a developer to freeze an application and its dependencies into an image as a part of build processes. The build process is part of software development lifecycle where applications and their dependencies are packaged together and tested prior to distribution and use. Then once an image is built, running the container images will always result in same configuration state. Container images are built from a source file known as Docker file. So they are a list of new line separated instructions that instruct the Docker daemon how to generate a container image. So there is a link given here where you can read and a big explanation of how to write Docker files. And one example of Docker file is given here too. You can check those out. So in our case, in the case of Grunge Enterprises, we don't have the original Docker file, but with the container image, we have something just as good. Let's start by creating a new directory and saving the downloaded image as a tar file. Okay, so let's exit. Then first we need to create a directory. Okay, let's go there. Then save the container image as a tar file. Okay, so for saving a container image as a tar file, we can use option docker save, then -o. Let's see. I think it will take some time. Okay, once we have saved the image, we can further inspect the image by unpacking the unpacking the compressed file. Let's see, we have aoc.tar. Now we need to unpack this. Okay, so V is for verbose. So now our files are unpacked. This file represents the various container image layers with the exception of manifest.json. This file represents the manifest of the container image layers that compose the final container image we were just inside. Now let's let's take a look at the image using a tool called JQ to print the output of easier readability. Okay, first let's try this without JQ. Okay, so you can see we are getting output in like a single line. it's a messy format. So what JQ will do, JQ will print it in a in a easier way to read. So on our tag box, JQ is now pre-installed and you can skip the step. So I'm in our virtual machine, in my virtual machine, so I don't think JQ is installed. So let's install that. We can use apt install JQ. Okay, then print the contents of manifest.json to the terminal using JQ to pretty print. Okay, let's read manifest.json again. This time we will use JQ. So yeah, you can see now we can read it easily in a easy way. So we have config, then repo tags, then some layers are given here. Okay, so the first piece of information in the file is config, which represents the underlying configuration and commands used to build the container image. So this configuration is also located in the root of the unpackaged container image directory. Let's see. Okay, so this is here too. Okay, and can be inspected in the same manner as manifest.json. So let's try same method here. Okay, so it contain more information. Okay, architecture, config, host name. Okay, let's see. The first section of the manifest configuration file walks through the final image configuration as intended to run on a local host system. However, the next section is of particular interest to an attacker. Let's see what's in the next section. Here's how the container image was built. You can see each section broken up by curly braces, and some of the sections have an extra line indicating empty layers true. Okay, you can see there bin sh again, apt get upgrade, install curl, install python, install pip. Many things were installed. So each of the sections are describing a particular command run by the Docker daemon at the time that the image was built, and if the image if the empty layer true configuration is not listed as part of the section definition, then the configuration layer is retained in the overall container image as one of the layers listed in the manifest.json. Okay, so we notice the container contains a tool called env console. Okay, I don't know what to pronounce. Okay, we can see it's here. It's here. Okay, there is a GitHub link. Okay, it was cloned from GitHub. This is pulled from GitHub. Reviewing the GitHub repository of this particular tools tells about description states. Its description states it allows a user to launch a sub process with environment variable using data from HashiCorp console and Vault. Okay, we can see the this tools repository here. Okay, it provides a convenient way to launch a sub process with environment variables populated from HashiCorp and Vault. This tool is inspired by env directory and env chain, but works on many major operating system. Okay, installation process is given here, then example is given here. Okay, let's go back there. Noting that this source code was cloned into root directory, perhaps there is something sensitive related to this tool that a regular container user is not intended to see at Greenwich Enterprises. So what we can do is dig through the image layers and see if we can find out what is so sensitive about this. Okay, so we can more closely inspect the layers by switching to the subdirectories presenting the layers in the unpacked container root directory. As we switch between these layers, we notice one layer of special interest. Okay, so let's see. So let's try going in one of those. Let's go in the first one. Let's see what we have. Okay, we have three files, one version, one tar file, and one JSON. Okay, so at the next step, we need to unpack it. Let's use tar again. Okay, it's done. Let's see. Okay, one TMP and one var file is there. Okay, so I can't find anything there. Mm, there is root and console, then some file is given. Let's try on another one. Okay, let's try third one. Okay, here also we have layer.tar. Let's okay, so we have same output here. Let's see. ls. Okay, so there is a root directory. Let's go there. Okay, so we have a config file, config.html. Let's see. The layer contains the config.html file. As we look at this file in the container image layer, it is clear that sensitive configurations are maintained in the file. So let's use Linux command line tool grep and see if we can return a secret or a token. And there it is on line 4 when grepping the string token. Okay, so let's try to grep token. Sorry. Okay, so let's see. Okay, so one token is here and rest every part is commented out. Okay, so that's all we need to do there. So let's go to the questions. What command will this container images stored in your local container registry? So it's docker images. Here, spelling error. What command will allow you to save a docker image as a tar archive? So we saw that it was docker save. Now, what is the name of file, including file extension for the configuration, repository, tags, and layer has values stored in a container image? So we saw that it was manifest.json. Now, what is the token value you found for the bonus challenge? So we just found our token value. Let's see if this is the correct one. Okay, so it's the correct one, and we are done with our day 18. So you can go and search more about Docker. So that's all for this video. I will see you tomorrow in day 19.